so the only way to find them now is to go through the computer's lines of code one by one.
How many lines of code are there?
About 2 million.
2 million.
Yeah.
If you're only going to learn one thing from Jurassic Park, it's got to be this. Your IT systems need to be built redundantly.
Why the hell would he turn the other ones off?
Really spectacular, spared no expense.
Top of the line.
Spared no expense. Spared no expense.
Really, Hammond? Then why did you only hire one decent IT guy?
I can't get Jurassic Park back online without Dennis Nedry.
Okay, I know. We shouldn't be learning IT from Jurassic Park. But it's true that high availability is critical in an enterprise-grade network. A single point of failure in the network is dangerous. There's no problem while the device is up, but if there's a failure, packets are dropped. Using high availability works around this limitation. If one device fails, the other carries on passing traffic. In this video, we'll have a look at two types of HA, failover and clustering. Please note that this is for the classic ASA image, which is different to threat defense. Failover mode has two subtypes. These are active standby and active active. Both types of failover use two ASAs in a pair. When using active standby failover mode, only the active node passes traffic. The standby waits and watches the active. If it sees the active fail, it takes over as the active ASA. The new active ASA continues to pass traffic. When the failed unit has been repaired, it remains in standby mode. The downside to this model is that half of your investment is sitting there mostly unused. On the upside, all ASA features are supported. Active-active failover also uses two ASAs. As implied in the name, both ASAs actively forward traffic. To achieve this, the ASA uses a special trick. Each of the ASAs runs two contexts. One context is active and one is standby. There are now 4 virtual firewalls running as two active standby failover pairs. The active context will forward traffic, while the standby context waits. If an ASA fails, the standby transitions to active and takes over the role of forwarding traffic. The good thing about active-active failover is that both of the ASAs are actively used. You're getting the full value of your investment. The downside is the added complexity, and that you can't use contexts anywhere else. In an ASA cluster, all units are active without needing to use contexts. The smaller ASAs can have up to 2 nodes per cluster. If you're using the 5585s, you can have up to 16 nodes active in the cluster. If an ASA fails, the other ASAs will take over forwarding that traffic. If you're fortunate enough to have the 5585 model, you can span your cluster across 2 sites. This is called inter-site clustering. Make sure you have a good DCI link though. It needs to be reliable, it needs to have plenty of bandwidth, and it needs to have low latency. The primary advantage of clustering is that all ASAs are active and contexts are not required. Also, you can use more than 2 ASAs, which makes it scalable. The downside is that some features are not supported in a cluster. Be sure to check Cisco's website to get a list of features that you can and cannot use. One final thing of note is that clustering only applies to ASA firewall functions. Modules, such as firepower, are independent and not clustered. Thank you for joining me in this brief introduction to ASA high availability. I hope you've enjoyed it. If you've enjoyed this video, or if it's been helpful to you, please like the video or drop a comment below. Please subscribe to this channel or follow me on Twitter to be notified of new videos and articles. Thank you for watching.